Yeah, then I think we can start. Once again, a warm welcome from my side to our today's webinar with the content CANopen FD. What is the current status? What is CANopen FD in brief? And what are the work items we are working on in the related working groups? My name is Rainer Zitzmann from CANopen. I'm guiding through today's webinar. I hold a degree in electrical engineering. I joined CANopen in 2004, and in the meantime, I'm appointed for general manager of the CANopen GmbH. This is the commercial arm of the CANopen Association. So we are a 100% daughter company, and we are providing all the services to the CANopen Association members that are intended by the management of the association. So if you are taking part in CANopen activities, you typically get in touch with my team and myself. Furthermore, I'm representing CANopen in international standardization in several groups, in the rail vehicle group with regard to energy management for light electric vehicle charging or power transfer, for garbage truck application standardization. And I'm furthermore a frequent speaker on conferences. We present CANopen on fairs, seminars, and so on. Yeah, so much in brief to my person. And I think it's worthwhile to introduce a little bit CANopen, who is CANopen, and what we are doing. Very in brief, CANopen is the non-profit international user manufacturers group that fosters the image of CAN technology and provides a path to future network technologies. It develops and supports CANopen and other CAN-based high-layer protocols. The association was founded in 1992 to provide technical product and marketing information to the CAN community. It is highly committed to support international standardization of CAN technology. So we are promoting CAN. So CAN has been developed for the automotive industry, but the use should not be limited to that application field, but we want to assist worldwide in any application the users of CAN. And we have established since these days a huge social network, so don't underestimate that. If you are taking part in CANopen, and if you're an active member, then you can benefit of these contacts, and also in your daily work, if you have any CAN challenges, then you can contact CANopen or can rely on the social network to overcome your challenges in a very short time. We are located in Nuremberg, so southern part of Germany, about 160 kilometers north of Munich. And here you see our contact details, and you can ask your questions and try at least in 24 hours to provide you with a corresponding comprehensive answer or context to our social network. Brief to the history of CANopen. So CANopen had been founded in 1992, so we celebrated our 30th anniversary this year. And as I've said, our main objective is to promote CAN. So therefore, we are publishing a magazine, the CAN newsletter, appears quarterly, and is a good mean for staying up to date, what's going on in the CAN market, in the CAN business, in the SIA community. All these things you can see there. Furthermore, you can meet us on fairs. So the first one had been the Intercama in Düsseldorf, where CANopen was present with a multi-vendor booth and showed interoperability of CAN-based solutions. And this going to fairgrounds we're doing also today. So in particular this fall, we had been at the InnoTrans in Berlin, where we assisted people in using CAN in rail vehicles. We had been in the construction machinery fair or trade show in Munich, the Bauma, and just last week we had been at the SPS. So it's still today possible to meet us there and to discuss technical related or marketing related questions with regard to CAN. So on the one hand, we do a global marketing for CAN, organize seminars, conferences, and so on. On the other hand, CAN automation serves as a neutral ground for specification work, so that companies can meet at CAN automation under patronage of CAN automation, and they can discuss there and can find solutions how they can develop their devices independently from each other, but these devices have a certain degree of plug-and-play capability in a certain application and can therefore be integrated without a big effort in so-called multi-vendor systems, or systems where different companies that have done their development independently of each other meet with their products. And the outcome of these specification work is then a CAN automation specification, and CAN automation maintains a lot of specifications. You see here, the first one had been the CR 102, where we summarized some thoughts where or how can a CAN physical layer for industrial applications look like. Then we see here the CR 301. This is the basic CANopen specification that appeared in the end of 1994. And we see that the work on the specifications has not stopped. We see there a very vivid activity at the end of the slide, where we see here that CAN FD, the CAN with flexible data rate, have been presented on the International CAN conference in March 2012, that we had here a working group that thought how to run CANopen on this new data link layer, CAN FD. The release was then in 2017, the first version of CR 1301, the CANopen with flexible data rate. And we are still bringing CAN FD into the market, but in parallel, there has started the development of a third generation of CAN, the CAN with an extended data length, or briefly CAN XL. And as I've said, there are still activities ongoing with regard to CAN FD. How can we calm down the ringing? Therefore, we have the evaluation of the CAN FD SIG transceiver. What about lightweight CAN FD implementations, the CAN FD Lite, and some further specifications. We see here we have a first specification with regard to CAN XL data link layer and transceivers, and this content has been submitted already to ISO for international standardization. So you see, CAN is still a vivid technology where we have ongoing developments. Also that we are talking about a live technology. You see here the amount of CAN automation members. So CAN automation has started in 1992 with 8 founding members. At the beginning of this year, we had 712 members. Today, we have 745 members. So CAN automation is still growing, because the CAN technology is migrating on the one hand globally, on the other hand from application field to application field. And despite there are so many other competing embedded network technologies, a lot of companies think that it's worthwhile becoming member of CAN automation, being member of the social network provided by CAN automation, and using the CAN technology. What are the advantages here? So on the one hand, you can take part in our marketing activities. We have their marketing activities with regard to CANopen FD, CANopen Lift, the municipal vehicles, and CAN XL. So what do these marketing groups driving these activities? They think about fairgrounds, where it is reasonable to exhibit and to show people that a corresponding CAN-based solution is attractive for this market. On the other hand, we evaluate, can we build, for example, demonstrators? Can we generate brochures explaining why it is reasonable to use CAN here or there? And what about language barriers? Is it necessary to overcome a language barrier? And do we have to provide the content in another language? Also, in CAN automation, for a CAN automation member, you have the possibility to join technical working groups. You see here on this slide our current working group. So it's maybe not complete because we have too many working groups, but it's showing which kind of working groups do in principle exist, where are our activities. You see here the technical committee steering our standardization activities, our specification work. And we have there a very vivid group, the lower layers group, talking about the CAN FD data link layer and physical layer, specifying CAN XL, considering CAN FD Lite applications, and some other things. So all these so-called lower layer related topics, they are managed by that group. We have CANopen. CANopen has, I would say, almost done its work. From time to time, there are some requests. These requests are solved, but in general, CANopen has been standardized and is doing its job. Then we have CANopen FD, mainly the same people that developed, or a big share of that people that have contributed to CANopen are thinking now how to use CANopen on a CAN FD data link layer. So there we have some activities. On the one hand, the maintenance of the CANopen FD specification. On the other hand, thinking about the additional application layer functions. Furthermore, we have also some people here in the CAN automation community thinking about J9039. So I think we have here also in the group some people from the railway business. So one application field where CANopen FD, and J9039 may meet. Therefore, it's maybe of interest to see that we have their activities, how to tunnel CANopen services via J9039, how to connect J9039 or CANopen based backbone networks on trucks to cloud applications, the DIN 4630. So you see also in this high layer protocol J9039 we have some activities. As we have here 3 different high layer protocols, it makes sense to describe the profiles independent, the data organization within the devices, independent of the type of the communication interface. So this is then done in the IT profiles. They say, okay, we want to think about the data arrangement of a certain device class, a drive, an I/O module, a component for an elevator application. And then they specify that, and in a second step, they have then the possibility to map this content to a certain communication technology like CANopen, CANopen FD, or J9039. We have further activities with regard to high availability. So currently, some people in the IT high availability thinking about dual mode redundancy and to lengthen the availability of the application, even if one communication channel is somehow damaged. And furthermore, we have the topic safety and security. So here we have people taking care about the subject. We have already a CANopen safety implementation specification already standardized on European level. And on the other hand, we are thinking about cybersecurity. There are also several activities running at CAN Automation. So if you're interested in that, I can tell you also about this later on, some information. Finally, there are some groups directly managed by the technical committee. So the task force bootloader and modeling. I think in particular, the task force bootloader may be of interest for this group here. How to update in a harmonized way devices that are maybe already installed in the field via the CANopen interface. Yeah, all the appointments of the group, all the meeting dates you find on CAN Automation's website. So you can be, if they're the source for information, and you find the meeting dates, and you can register there for the next meeting. So briefly summing up, what is CAN Automation doing? We are taking care about the CAN Automation specifications. We are maintaining them. And on the one hand, we are promoting them by our publications, the CAN newsletter, our product guides. You find there the corresponding implementations by brochures being informed about the existence of these specifications and their advantages for device designers, system designers, and maintainers. On the other hand, we are providing technical services like consultancy services. We are explaining how is a certain specification meant. We are offering testing services for CANopen and CANopen FD. And we are also offering interoperability testing or briefly plugfest for certain application fields. If you want to be informed about the latest movements in CAN automation and CAN, then consider our publications. For example, if you register for our email services, then you will be informed monthly what's going on in the CAN market. On the other hand, you can consider also our application for placing advertisement, or by submitting technical articles, you can inform the public about your latest solutions. Finally, last words about CAN automation. The main benefit of a membership is that you have access to all the groups, all the documents, all the meeting minutes, that you see what is specified. You can scan for the reasons why was it specified in this way, not in that way, by reading the meeting minutes. And you can influence the specifications by submitting comments or taking directly part in the group, and therefore establishing and strengthening the relations to other CAN automation members that may help you in your daily work, also for overcoming CAN-related issues. Yeah, so much with regard to the CAN automation advantages. Now our group got a little bit larger, so therefore, once again, warm welcome from my side with regard to our attendees, and thank you for attending this webinar. And we're coming now to the core topic, the CANopen FD, a little bit the status and the update, what's going on with regard to CANopen FD at CAN in Automation. Yeah, let's have a brief look at the milestones of CANopen FD. So CANopen FD had been developed by the IG at CANopen FD, and we have shown already in first workshops that everything is working as intended. We demonstrated it on fairs, and in 2017, in September, we released the first version of CANopen FD, the SIA 1301 version 1.0 as draft standard proposal, and CAN automation members have access to that via the CAN automation's website. We have already exhibited at the SBS IPC Drives in 2018, so already prior to the Corona crisis. First CANopen FD devices on our booth at the SBS. And in the meantime, also at the last SBS last week, we had some CANopen FD devices on our booth. So, and we had also first requests with regard to CANopen FD. So we see there is an upcoming interest in CANopen FD, and therefore it makes sense that we're talking also today about CANopen FD. Just to take you with me, so CANopen FD is based on CAN-FD. CAN-FD, we see here a comparison between classical CAN and CAN-FD. What is CAN-FD? How does the frame format look like? So CAN-FD and classical CAN are rather similar. They have the very same frame format, the very same bit fields. The bit fields themselves just differ in the size. So we see here in CAN-FD, we have a control field using 9-byte instead of classical 6-byte. We can transfer up to 64-byte of data and secure this data via 21-bit, in a maximum of 21-bit CRC checksum. And finally, we have our acknowledge and the end of frame. So we're seeing the frame format that is itself, it looks identical, and it just differs in the size. And we see here the email, the data field, we can transfer with an accelerated speed. So if we want, we can switch in the control field to the higher bit rate and can transfer the rest of the frame up to the acknowledge field with the accelerated speed. So in case of doubt, I'm using 2 bit rates for transferring 1 CAN frame. So this allows us to increase the data throughput, but this allows also to make use of additional data bytes. And we see this here a little bit more in detail. We are switching if we want to at the sample point of the bitrate switch bit to the accelerated bitrate used in the data phase. So I don't want to go into the details of CANFD. We just know, okay, we have now a data link layer available that is capable to transfer up to 64 bytes in 1 frame. In minimum 0, but we can turn up to 64 bytes. And to deal with the latencies, to increase the data throughput, we have the option to transfer the data field and also the CRC field with an accelerated speed. So we see at the end of the CRC field, at the CRC delimiter, we are switching back to the communication speed that we have used during the arbitration. And these 2 features we have to consider. So we see here, we can already gain data throughput if we increase the speed, but if we keep the payload stable at 8 byte. So we see this here, we are starting with 500 kilobit, and then in the data phase, we are turning up the speed up to 4 Mbit, and we see we are ending up at an average speed at about 1.4 Mbit. So this means we have already an increased data throughput. But if we want to make full use of CANFD, then we have to use also lengthened data frames. So we increase the amount of accelerated bits. We see this here up to 64 byte. And then we end up in the setup that we have 500 kilobit in the arbitration and 4 Mbit in the data phase at an average speed of about 3 Mbit. So what is important to remember is that we have now 2 features. We have the lengthened data field and we have the increased speed. And both features we can deal with separately. So we did an inquiry in our member space, and the result was that most of our members are interested in some additional data bytes compared to these classical 8-byte payload, but they are not that keen on using high bit rates. Maybe in the meantime this may change, but in general they say, well, in an average CAN network we don't have any bus load issues, but we need, for example, for authentication purposes and other tasks, some additional data bytes, and therefore the 8-byte data field is a little bit too small. And CANFD allows you to fine-tune the usage of the bitrate and the data field, fine-tune this to your requirements in your application field. So, for example, if you run today 250 kilobit, then you can say, okay, I just jumped to 500 kilobit and therefore I can mainly reuse my topology, or maybe even a jump in the bitrate is not necessary at all. Then you can stay with your today's topology, but you can use a 16-byte frame or a 20-byte frame. So you can use these additional bytes, but you don't have any impact to the topology that you're using. The point is, the faster you're communicating, the closer you have to evaluate your topology, because then you're running in some physical effects and you have to qualify, re-qualify your physical layer, whether your physical layer is capable to run an increased communications. And in particular, if you exceed with a data rate in the data phase, the 1 Mbit, then you have to take specific measures to make your network functional, to make your network work. Otherwise, if you're under this 1 Mbit, then in general, it's not that tricky to make the CANFD network running. under all circumstances. But with regard to CANFD physical layer handling, we have there also some other videos available on our YouTube channel. So maybe you'll find there some further notes, and I will say later on something to the physical layer. For the moment, I just want to say we have two features. We have the data field and we have the communication speed, which we can separately choose the right settings for our application. So it would be also, for example, for a migration path, okay, to say, well, I take a classical CANopen stack and put it on a CANFD controller, and this CANopen stack can, of course, run only 8 data bytes, but we have seen on the previous slide, I can already gain data throughput in the setup, and I would have an ideal transition path for migrating from classical CAN to CANFD and from CANopen maybe to CANopen FD. If I want to make full use of CANFD, I need a higher layer protocol stack that is capable to make use of the full 64-byte of data provided by CANFD. So the data rate, this does not care more or less the protocol stack of a higher layer protocol, but the data field, of course, at least you have to adapt your thresholds that you are not limited anymore to 8-byte, but to 64-byte. Then you have to think about how to use the 64-byte of data. Do we need to declare the data somehow to the protocols? So all these things have to be done. And I've already said in 2017, we have released the first version of CANopen FD. And since 2018, protocol stacks, first devices are available. So from that, we are almost ready, or we are ready to start. And we see here depicted CANopen FD is the higher layer protocol, and all the CANopen FD services go via CANFD frames, and all of these CANFD frames use then the CANFD physical layer to transfer the signals from one CANopen FD device to one or several other CANopen FD devices. I assume that you are rather familiar with CANopen. So the good news is, in a CANopen FD device, the device model is more or less equivalent to that of classical CANopen. We have only some small differences. So CANopen FD device, of course, resides on a CANFD device, and from that CANFD device, the CANopen FD device inherits the bitrate or the bit rates. I have now not only to deal with the nominal bitrate, that is that one used in classical CAN or during the arbitration phase, but I have also to deal with a bitrate that shall be used in the data phase. So those are inherited by the from the CANFD device. Then the CANopen device itself has not only a node ID, but deals now with a network ID. So if you're a little bit more familiar with CANopen, also you're familiar with a network ID. A network ID had been introduced in the document 302 for CANopen. Here in CANopen FD, we directly use the network ID in the basic CANopen FD specification 1301. Also in CANopen, we have an object dictionary, we have an NMT management, we have so-called the NMT server, we have the error handling, we have logical devices and manufacturer-specific functions. So this is already there. What's maybe a little bit different that we're considering in the basic CANopen FD specification, also the manager functionality for network management. In CANopen, we have this exclusively in the document 302. When we have it here in the basic CANopen FD specification, it allows us also to consider the network management state machine for the manager device. When is it active? When can we issue certain commands? Yeah, so the good news, I can reuse my device model, let's say to 90% I've learned for CANopen, I can reuse that in the CANopen FD use case. We have seen on one of the first slides with regards to CANopen FD that CANopen FD is a CANFD based higher layer protocol. Therefore, we are focused on the services. How does CANopen FD use CANFD? But nevertheless, we have some expectations in CANopen FD, how the lower layers should be implemented, as we have this in CANopen. Here in CANopen FD, we are in some share a little bit stricter, considering the bit rates and the bit timing, so we have to be there very clear. Otherwise, CANFD would not work out of the box. And so furthermore, we have to consider all the invaluable information that had been developed already by the lower layers group in Canon automation, and all these learnings are saved in the document CA 600 in this specification series. So a lot of valuable information that had been generated during the CANFD standardization process we saved in this document series, and this should be considered when making CANopen FD. With regard to CANopen FD physical layer, as I've said, we are talking about the bit timing. You see here the pairs of bit rates that should be supported by any CANopen FD device. We are currently discussing about this first yellow line, so I think this will drop out for the next version, because in contrast to our expectations, most CANFD controllers support 40 megahertz, not 80 megahertz, and then from the bit time registers, it's very difficult to achieve this bit timing setting, respectively these bit rates. We see here at the next slide the current edition of the bit timing tables that are based now on 40 megahertz. So on the version 1.0 of CANopen FD, we have a table inside that is based on the 80 megahertz clocking. As I've said, most of the CANFD controllers are based on a 40 megahertz clocking. Therefore, we have to adapt our table, and the 40 megahertz clocking in conjunction with the size of the registers, of the bit time registers, makes an adjustment of the 5 mbit very tricky. Furthermore, we have learned now the usage of the CANFD SIG transceiver. So the CANFD SIG transceiver has the capability to calm down ringing. So if you have a very disturbed network, you can calm down by the SIG transceiver the ringing, and therefore also in networks deviating from the line topology, you can run CANFD. That's the good news. But the problem is they, let's say that way, for this calming down of the ringing, they take a bit from the propagation segment, and therefore the overall length is a bit limited, or respectively the communication speed that can be achieved during the nominal phase is limited. So with the SIG transceiver, I think communication speeds exceeding the 600 kilobit in the arbitration phase is not reasonable. So you are ending up in the arbitration phase at about 500 kilobit, but therefore you can very properly jump to high bit rates in the in the data phase. So this is the usage of the SIG transceiver. Also here we have a separate video for that. But for the moment we see, okay, for the average usage, you see here now the 40 megahertz table in CANFD. It's very important that all the devices derive their bit timing, the bit rate from the very same bit timing table, from the very same bit timing registers, and they are based on the very same clocking. So if you're staying with this table, you should be very safe in the CANopen FD networking. One problem in CANopen FD had been that we are very clear with regard to topologies in, let's say, rather small network extensions, networks that are, or that follow topologies similar to that used in the automotive use case. we have only few experiences with regard to the usage of CAN-FD in large topologies. So just recently, mid of this year, some people from Kongsberg came to CANopen and said, we want to use CAN-FD in cargo ships, and could you assist us in making this functional, making this work? And so the people from Kongsberg, they presented their use cases, what are the boundary conditions, what is the arbitration phase communication speed, the data phase communication speed, and we see here, we have here network lengths of about 250 to 500 meters, and under which boundary conditions can we make CAN-FD work here, and they want also to use CANopen FD and the functions of CANopen FD. And here in this research project that we are working now in a CA working group called the SIG large CAN-FD, CAN-XL topologies, we are summarizing these boundary conditions. So therefore, also from my side, a warm invitation to you. So if you have any requirement, because you say we are also in applications active where we have long-lasting networks, like in rolling stock applications, in truck-mounted applications, elevator applications, and so on, then please submit your requirements. What are your typical networks, your typical amount of devices, your communication speed? What is your, let's say, target of communication speed or data throughput? And then we can consider this also in this working group. So we see here what we want to consider. The objective is a specification of a reference topology that could be used in long non-automotive applications. As I summarized, what about the supported bit rates, network driven? What about the galvanic isolation, the connectors, or what about requirement with regard to the devices and the hardware themselves? Do we have EMC requirements, specific ones? So all this we are interested in. Please submit it, that we can consider it, take part in the working group. You see here the scope of the working group is to generate a specification of a CAN-FD and CAN-XL physical layer that works for the given boundary conditions, such as bitrate topology, cable parameters, transceiver and controller characteristics. So this will allow system designers to use CAN-FD or CAN-XL, even if they are not in the position to qualify their networks comprehensively. So you see here also an excerpt of the upcoming meeting in January. So there's a little time for you to make some thoughts and to take part. Yeah, with regard to the already existing specifications with regard to the CAN-FD physical layer that is utilized by CANopen FD, you find here an overview of the CIA 601 series. And here the aforementioned SIG transceiver you find here, the specification for signal improvement circuitry you find at the -4. And that one that is in italics, the -5 series, this is more or less then the result, or will be then the result of the aforementioned activities with regard to long network topologies. This is not a physical layer seminar, but just a summarization of what we are doing with regard to CANopen FD. Therefore, I like to give a link to our YouTube channel, Canon Automation. And here we have also some very in-depth information videos from our last international CAN conference. This is now, since this year, available for the public. So you can see here some information with regard to designing CAN-FD high-speed networks, improved CAN drivers, or physical layer options. So please have a look on our YouTube channel and you will find this. Coming back to the CANopen FD details, we are still somewhere in the area of the physical layer and the lower layers and the the settings that we need for making a CANopen FD device working. And I've said we have a node ID. For the node ID, everything is identical. Then we have it in classic CANopen. But in addition to that, we have now a network ID. And the network ID informs now the CANopen device to which CANopen FD network is this device attached. So if I'm thinking not about a single embedded network, but an entire embedded network architecture, then we have here now the possibility to tell our device in which network segment of this network architecture have we connected this CANopen FD device. And we will later on see we have in CANopen FD services that have the capability to communicate over local network borders, to exceed the local borders or the limits of a single CAN FD network via gateway application. They can communicate in the entire network architecture, and therefore it is necessary to know on which to which network is this device connected. And nevertheless, in many deeply embedded network, we don't talk about this network architecture, so we have a kind of default value, it's the 0. But as soon as I know to which networks I'm connected, if the device shall be active in such a network architecture, we also can handle this now thanks to this network ID. The setting of the node ID and the network ID is identical, so I can take all the learnings from classic CANopen. We have improved in the meantime the layer setting services for CANopen FD, so we can adjust via layer setting services not only the node ID but also network ID as it's specified in CL 1305. And we have also an improved service for finding a device, so we have not only a one-way communication as in classical LSS, but the end devices themselves can say to the LSS manager what is the next part, the next share of the LSS address they are supporting. Therefore, searching algorithms for is there somewhere an unconfigured device in my system can be accelerated, can be shortened, and I can very quickly find all the unconfigured devices in my system. Also to that, we have already a presentation on YouTube given by my colleague, Ms. Young. The final state machine with regard to network management, we see here, it is almost identical to the classic CANopen specification of the state machine. There we have a classic CANopen. So we are starting, we have our initialization, and we have then the pre-operational, operational, and stop. The only thing that has changed from CANopen to CANopen FD that we inserted some clarifications so that during communication restate, substate, we apply the node ID. This is important for all the devices that have, for example, no non-volatile memory. They will lose their node ID settings if they are if they go power off. And when they come back, they have not necessarily a node ID yet, so they got stuck somewhere here in communication reset. So we know now it's not somewhere, but it's here in communication reset. They are waiting here for node ID and network ID settings. Then they can finalize the initialization of the communication objects and the node ID and the network ID, and then they can start up to communicating and enter the pre-operational state. And we have also clarified when do we start up a manager FSA. So for example, the FS final state machine for a configuration manager, a device that is monitoring who is active in my network. Are the devices connected that I need for my application? Are they configured in the right way? All that is now starting when I'm entering the communication state. So you see, with regard to the device architecture, most of the things were kept stable. With regard to the services we see here, we did some analysis, so not change everything, but only change those services where it's really reasonable to change something because I have a certain gain, a certain advantage, and I can maybe overcome existing limits. And therefore, as a result from this analysis, we saw we can differentiate the services between network management oriented services and data transport oriented services, and all these network management oriented services we see they are not really limited in their performance by the CAN data link layer. So they use a payload of 1 byte, 2 byte, one exception here, the timestamp with 6 byte. So they don't use the full payload provided by a classical CAN frame. And therefore, there was said it's not reasonable to change there something. It's a more advantage to keep everything as it is in CANopen. For the data transport oriented services, we said, okay, they are really limited by classical CAN data fields. And therefore, here it's very reasonable to have a closer look and how can we adapt them to make them more efficient and to increase the data throughput there in CANopen FD. And let's briefly rush through these services. We see here the emergency write protocol. And in this dark green, we see this is the content of the old-fashioned emergency write service as we have it in CANopen. But this information provided by this emergency write service has now been enriched, for example, by a timestamp, by a status about this error, and by some location information where in the device occurred this error, if I have a very complex device following several logical devices, or if I have several logical devices, which kind of CA specification specifies this error. So I can now provide more detailed error information. So we can store these errors in a so-called active error history. I have there an entire domain with comprehensive management functionality where I can handle this domain, these entries, and not only during a single system runtime, but over a longer period of time, I can now store all occurred errors to this error history. And with the accompanied management functionality, I can control this error history and handle this error history, manage this error history. And then I come with my diagnostic laptop and download the entire content for closer analysis. So this is the error history domain. For direct reaction during system runtime, we have an additional error history or error listing where only the currently active errors are provided in a concise format. So we have here always the latest error in the first parameter, and the other ones are moving one entry down. So the latest one always in entry 1. And if an error had been resolved, it is removed from the list. So via that, I see only the active errors here. So much with regard to the error handling. With regard to process data, you may know that we have in CANopen a process data object carrying the process data and receive and transmit direction. It's called the process data object, and we can fill up via a mapping table our process data object up to 8 byte. The 8 byte limitation comes from the classic CAN data frame payload. So the only thing what we had to do here with regard to the PDO was to increase the threshold from 8 byte to 64 byte, and then we can use the mechanism well known from classic CANopen via the mapping table to fill up now 64 byte with the very same technique as we did in classic CANopen. The only thing that we have to mention here is we have a further rule with regard to the smallest unit that we can map to a PDO. In classic CANopen, that had been 1 bit. In CANopen FD, this is 1 byte. We said we are anyway on a byte-wise oriented medium in CANopen or in CAN, and therefore it does not make sense to map smaller units than 1 byte. And if we have this rule that we map as the smallest unit 1 byte to a PDO, this allows us with the existing mapping table, the mapping table that had already been invented for classic CANopen, to reutilize that for CANopen FD for filling up a 64-byte CAN FD data frame. Just a small reminder, CAN FD data frames cannot be always adapted to the real required payload, but can only be extended in certain steps. So we see this here. And what does this mean? We should consider padding bytes, that we do not transmit any rubbish that is occasionally in the memory cells, but only intended data. And also with regard to the publication of version 2.0, I can say we had some discussions in the group clarifying how should a CANopen FD device behave if a certain service is received by means of a CAN FD data frame that has more or less data bytes than expected. So this will be one of the major changes or amendments in the version 2.0 of CANopen FD compared to version 1. The advantage of the extended PDOs we see here, we have more data size therefore available, and we can control easily several drives synchronously by one single frame. For example, here up to 8 axles, as we have mapped the control word of up to 8 axles in the drive specification, the drive profile 402-6. So something like that does already exist and eases the handling of very complex applications. And as I've said, you can also use the extended data feed for other purposes, for example, for cybersecurity or whatever. With regard to CANopen SDO, the update was not that easy because the SDO itself in classic CANopen is rather complex. And then when we thought about the updating of the SDO, we also thought the SDO comes from a time where we had in mind that there's always a system designer out there configuring communication channels between the devices, configuring everything. But in modern applications, this is not always the case. I need dynamic cross-communication, not only in a one-to-one session, but sometimes in a one-to-n session. And so these things are possible somehow in CANopen, but it's often tricky, and often the device implementations bring me to certain limits. And therefore we said, why not overcoming these limits? And as a result, we said one of the most limiting factor in CANopen SDO communication is that always the server determines the CAN identifiers that are used in our SDO default communication. And in CANopen FD, we said we want to overcome these limitations, and we have now more processing power on the CAN controllers, and therefore we can say we communicate with the CAN identifier determined by the sender, not by the server, but by the sender. And the destination of this CAN frame is coded in the first data byte of the related CAN frame. So this is now a big difference, but gives us a high design flexibility, as by modifying just the data field, we can determine I want now to talk to him, or to him. And the devices themselves, they just filter on the first, not only on the CAN identifier, but also on the first data byte. And then they see, okay, this is a message for me. and then they process the inquiry and provide the answer, and therefore the client gets the answer. So this small change provides us with a high design flexibility. And this is then provided by the so-called universal SDO, or in brief, the USDO. It has a full function coverage of the classical SDO, but in addition to that, we have now here also, some extended functions so that we can communicate in multicast or broadcast, that we have an accelerated transfer for very large data packages. We can dynamically, during system runtime, establish cross-communication between devices. We can have parallel communications with the USDO. So one USDO connection is running and I can start a second one or a third one to the same device or to other devices. So a very high design flexibility that is now provided by CANopen FD. Yeah, let's have a brief look on the telegrams. How do they look like? We see here the protocol is designed like that. The first byte is always the destination address. Who shall be the receiver of this segment? It may be a specific device identified by its node ID. It may be a group of devices, or all devices in the network shall accept this, this segment of the USDO. Then in the command specifier, I say which type of SDO communication do I like to have. The session ID allows to handle several transactions, so the same to other devices. We have index, sub-index. Maybe here once again, you may wonder, why do we provide sub-index, index in a swapped way? Why first the sub-index and the index had been different in the past in CANopen? The reason is because we want to get rid of this bit flipping, as it is known from the CANopen SDO, and we had an eye on byte alignment when we were specifying this USDO, or also the emergency service, for example. Furthermore, we declare the data with regard to data type and size, and then we hand over the application data. And you see here, with regard to the response, we adapt now the response with regard to the real needed payload. So we don't, as in classic SDO, shift CAN data frames with the maximum amount of payload, but we adapt it to the real required one. Also, this will save bandwidth and increase the communication speed. So, as I said, I don't want to go into all the details. I just want to highlight that one here, the bulk transfer intended, for example, for firmware updates, or maybe updating process images between host controllers. So you just negotiate what are our communication capabilities, does everything work, in fact, manage some timings, and then you can say, okay, everything is fine, and I send one data segment after the other, and at the end you say, well, I understood you, yes or no. So if everything is fine, this is a very fast, rapid way to update the devices. For example, download configurations to several devices that have to be configured prior to a session in the identical way. So for example, in a knitting machine, hundreds of motors, in a pleasure boat, several motors doing exactly the same, or in a seeding machine. So there exist various applications where you have to handle several devices in a very same way, and then you can accelerate the device configuration enormously. In CANopen FD, we had also a special eye on error handling and diagnostics. So we forced the CANopen FD devices to provide more diagnostic capability. Therefore, we have also redefined the error codes with regard to the USDO, but also with regard to emergencies, so that we get more diagnostic information and that we can keep the standstill times of CANopen FD based systems low, because a system maintainer may very rapidly get the information, what's the problem and how to overcome the problem. Here, just some ideas when it can be beneficial to use now this USDO, for example, for accelerated download of firmware, of configurations. And you see here just the use case in the end-of-line production. In classic CANopen, this would be single SDO accesses. In CANopen FD with the USDO, this is exactly one access. And how much you gain in time gets more and more with the amount of devices you add here to this network and you configure because for classic CANopen, this would be always single accesses from device to device, and here we do everything with one broadcast access. And we see here, for example, an example of a Pedelec, a typical device where the end user is modifying the application by adding batteries, by adding displays, by adding some additional features. And I don't know exactly what is the current setting, but no problem with regard to communication coherences, because as the USDO has such a high design flexibility, all the devices can themselves explore who else is with me in the system and to which device I want to start up communication coherences and how to get, for example, everything that I can show all the statuses of the attached batteries to the display. Or a service tool. That service tool can have access very simply during system runtime to all the devices. So in classic CANopen, a very critical thing, in CANopen FD, very easy access without disturbing the currently running application. IoT gateway is the very same thing. If I set up a system, I have no clue what will be the use case for a remote diagnostic, which parameters need to be accessed via an USDO. Every parameter would be, in principle, accessible also in future. So we have already started with some work in the document CR309 for classic CANopen, and we can reuse this in conjunction with the USDO in a CANopen FD environment. But the USDO, as I've already mentioned, does not only consider local networks, but also remote networks. You see here, I can, every command provide in a local addressing or in a remote addressing or long distance USDO upload request, if we call it here. And every CANopen device in minimum has to accept, as it is written here, the expedited services. So in principle, this would allow me a full access over network borders and is accepted by any CANopen FD device. So in particular today, where I don't have many applications, a single network, but cascaded CAN network technologies, a full access to my application from a single point. This helps me also out with regard to migration passes. So the best migration path from CANopen to CANopen FD, if I have to consider old CANopen based applications, would then that I have a gateway on the one hand, CANopen, on the other hand, CANopen FD. And with regard to the SDO communication, we know we have already with the SDO and the document 302 a remote SDO handling, and we can initiate then accesses in the CANopen FD world. And as we have with the SDO communication, mean that has full function coverage of the SDO, this communication direction is no problem. The other way around, we have to say, yes, if we limit us to the function coverage of the classic SDO, then this would also be a one-to-one mapping. If we're using at the USDO side commands that exceed the functionality of an SDO, so for example, a broadcast command in the remote network, then we have the situation that we have to consider here some timeouts in this situation that tasks take some time, and we have the situation that the gateway itself may get transparent because it has to inform us about the progress of the command handling or some abort codes or whatever. But in principle, also for that, we have a solution, and we find already devices on the market for that use case. As I've said at the beginning, we are in the CANopen FD working group, thinking about the release of the version 2.0. It was intended for this year. I have some doubts that we can manage it. I think it will be beginning of next year. But one of the major changes or add-ons to this version 2 is the adjustable available payload. So what's that? In principle, we can assume that a CAN-FD frame provides us with up to 64 bytes of payload. So you can say, okay, anyway, it's adjustable. If I just want to use 32 bytes, then I use 32 bytes. So where's the problem? This is correct, but the point of view is a different one, that you say, okay, for some other tasks, somewhere in the middle, maybe security tasks or other applications, I want to reserve a certain share of the data field of the CAN-FD frame, and therefore I provide to the stack, to the higher layer protocol, only a limited amount of the application data, of the data field. So for example, that you say, okay, I always want to secure my application data via checksum for safety reasons, for whatever. Then I can say, okay, I provide to the stack, to the CANopen FD stack, only 32 bytes. And the rest I use for this security checksum, for example. There exists another use case. For example, if I have an attack vector, let's say, okay, I know my corresponding process data I'm looking for comes always with 48 bytes. I can say, okay, I don't want to show that this content is coming now because I vary the frame and say, okay, sometimes I send it with 48 bytes, sometimes I send it with 64 bytes, fill it up with some rubbish data. But my application knows, okay, I can only fill up from byte 0 to byte 47 with the real application data. So there exist several use cases when I want to use some shares of the data field provided by the data link layer for other purposes, mainly for cybersecurity control purposes, but I know also other use cases. And to allow something like that, we have here the possibility to tell our stack, okay, only a certain share of the CAN-FD frame is for the CANopen FD data. The rest is for some lower layer functionality. Here I summarize all the objects that are new. So in version 2, we have, I think the only really new object is then this 1042 for the maximum available payload size. All the others, they may be fine-tuned, there may be some additional explanations, but they had already been in CANopen FD version 1.0 and have already been explained. I like to remind you that in CANopen FD, we have an obligation for testing. So if you want to call your device a CANopen FD device, it has to be tested here at Canon Automation Office. Together with the test, we need a device description. It's an electronic device description and XML-based description as specified in the specification 1311-1. With regard to the availability, so CANopen FD stacks are available from several companies. I've listed here some. We have also first devices available. Also here device manufacturers are listed. I think one is already certified. The others are at least under testing. And we have already a manufacturer of gateway applications from Peak EMSA. They are already tested, certified here at our Canon Automation Test Center. And as I said, we have already some solutions for security controls. latest news you find always in the CAN newsletter. Therefore, I have here also a page from the newsletter depicted. So also the address. So I don't say that this is a comprehensive overview. If you know about further implementations, please submit them to SEER so that we can list them. Yeah, so much in brief with regard to CANopen FD. So the major functionality, of course, remains unchanged compared to CANopen. We have now 64 byte data field that we can use fully for the PDOs. The SDO is substituted by the USDO, a very powerful service that has full function coverage of the classical SDO. But in addition to that, we have the ability of a dynamic cross communication that can be established during system runtime. We can provide not only a one-to-one session, but also broadcast communication, one-to-N sessions. So a very powerful mean for embedded networking. In addition to that, we have some enhanced diagnostic functionalities. As I've already explained, the IT CANopen FD intends to release the CANopen FD specification version 2.0 soon. So I highlighted during my presentation always the latest extensions and planned modifications. Furthermore, we have other working groups that are working with CANopen FD or somehow related. So we have in the IT profiles a lot of work updating our CANopen device profiles for making them use of CANopen FD. So therefore, one of our next activities will be the use of CANopen FD in the application field of energy management and battery management. We have also the specification of gateway solutions. So for example, with regard to J9039, so how about the connection to the cloud and these kind of things. We're having in the moment also this dual mode redundancy activity. This is something running under CANopen and CANopen FD or J9039. How can I handle several independent communication channels to allow then on the top of that a CANopen FD application? And we are also thinking about a CAN bootloader applicable not only for CANopen, but also for CANopen FD. And furthermore, if you want some more details, of course, there exist some seminars, but also on our YouTube channel, we have a lot of interesting information there. And finally, I'd like to remind you on the project of our SIG large CAN FD, CAN XL topologies, where we evaluate how can we run CANopen FD, CAN FD in applications like cargo ships, vessels, trains, truck-mounted applications like cranes, aerial working platforms, and so on. Yeah, so much from my side for the moment. I hope I could provide you also with some new insights to CANopen FD. Don't mix it up with a CANopen FD seminar. As I've said at the beginning, I just wanted to highlight what's the status, what are the work items, and what are the latest modifications of CANopen FD. I hope I could provide you with such an insight. And so I like to remind you on our workshop with regard to battery and energy management. So I know here on the slides it is a little small to read, but you will find it also on our homepage. Will be mid of December, 13th of December, you'll find it. So if you are interested in the subject, I'd like to invite you. We will have there a short presentation up according to the agenda, and then hopefully a discussion what are the requirements, how can we meet them in the best way with regard to CANopen and CANopen FD. Here you see a short screenshot of our website. Here you find everything. In particular, here the lower part we have here in this chapters for meetings, trade shows, technology days, webinars, seminars. You will see what kind of events are upcoming, what kind of activities, and please feel free to register. And I would be very happy to meet you again in one of the activities that are upcoming. Yeah, that's all from my side. I thank you very much for attending. So I wish you a nice evening and hope we meet soon on any other occasions, and much success with your CAN-based projects. Thank you very much. Bye.